This video is about the shape database in COMOSYS. And the first thing which I want to say over here is why have a shape database? So the idea is that normally COMOSYS is a detailing software, which means you can enter your beams and columns and your plates and your bolts and your welds and make cuts, and basically you're creating an item which you can't really buy off the shelf. I mean, there's no such thing as an off the shelf building most of the time, right? So what you do is you create you detail something according to the requirements of that particular job, and obviously then you have to draw your own shop drawings for that, because what you are creating does not exist in the supermarket. You can't just go and buy it from someone, so it needs to be manufactured. But there are lots of things which you can buy off the shelf and which don't need manufacturing shop drawings. I mean, the company which manufactures that object will obviously create its shop drawings, but you don't need to create those shop drawings. All you need to do is just specify the name of the object or the catalog number, for instance, and you can just buy as many as you want of those objects off the shelf. It is the modeling of those kinds of objects which don't really require specific creation of shop drawings, for example. Although, I mean, you can in COMOSYS create shop drawings of those objects as well, but if you did it. But the point is that the idea behind the shape database is to create these shapes which you can then use on multiple locations in the project, and basically the same shape keeps repeating itself in different orientations. Now, obviously, because it is the same shape which keeps repeating itself, this has the advantage that you can save a lot of memory as well, because even if you have, say, 500 instances or 1,000 instances or 10,000 instances of that object, in reality, you just have one definition which is being repeated again and again. So if you have an object which you're not going to change, which you're not going to detail in some way, you just basically picking it off the shelf with a well-defined shape, it's a very good idea to use your shape database. And then the another advantage is that you can create complex shapes, theoretically as complex as you want, and define them by using the primitives which we will talk about. So any shape of any arbitrary complexity can be modeled in the shape database. So what could be examples of things you could make with the shape editor? So it could be things like rebar couplers, for example, which are sold off the shelf. Different manufacturers have different types of couplers, and they all have different geometries. But the common thing is that they're available off the shelf. You just need to know the product code, and you can order as much as you want. So you could model your rebar couplers. Similarly, you could model if you have some standard embedded part in your concrete, which basically is you just buy from some manufacturer. Or you could what you could also do is maybe model your turnbuckles, for example, in steel connections or in cable connections, for example. This is once again an example of something which you buy off the shelf. So these are the kinds of things which you would typically basically create in COMOSYS using the shape editor. For example, you could also use rebar spacers, which are used heavily in the concrete industry to when you're laying the steel to ensure that the clear cover is maintained from all sides. All these are examples of things you might want to model in your 3D model, and you might want to show them. And for that, a very good idea would be to use the shape editor. So how do we go about creating these shapes? Well, what we do is simply we can create these shapes by using these primitives on the right hand side. And it's not just limited to primitives. You can cut them if you want. You can use all your cut commands. You can even use the normal steel plate commands, for example, or even your beam column command. So if you're creating a little complicated object over here with a little profile in there as well, you can do all that. You can basically use any shape which you want, and you can use multiple shapes, and then it will be combined into one final shape. So you can use the primitives, like I said. You can create extrusions, you can create surfaces of revolution, you can use the basic primitives of a box or a cylinder or a cone or a pyramid or a sphere or a torus or a transition solid, for instance. All these shapes can be used, and like I said, you can cut them, you can modify them, and finally the final shape which you are satisfied with will be put into the shape editor. So let's do a simple example over here. Let me zoom in over there and let's create a little box. So let me just select a point and right click, and immediately a box is created. And let me double click on the box. As you know, these are parametric objects, so you can double click on them and then you can modify their properties. So I'm going to make the sides 200 on both sides. Then what I'm going to do is I'm going to create a little point in the middle. So let me just snap from there to there and create a dividing point. So I'll know this is the midpoint and the sides are 200. And let me go to my cone command over here, for example, and select this point and then right click and create a cone on top of that. And then what I can do is I can create another point, another dividing point, say from here to here. And I've got a point in the center. And on top of this, I can put a little cylinder. And then what I can do is I can double click on this one and give it a shorter height. For example, let's give it a height of 50. Obviously, they're all parametric. You can keep on doing. You can create much more complicated shapes. So I don't want to waste time on that. But the idea is that once you're satisfied with the shape, one more thing you need to do as well is that before you enter the shape editor, you ensure that you have your origin where you can put your origin anywhere you want. So you have your origin points snappable. So I want my origin, this point to select, to this point to represent the origin, this point to represent my x-axis of this entire shape, and then a point over here to represent my y-axis. So as long as you have the points ready on the screen, because it's going to ask you for those points in a second when we go inside the shape editor, it's going to ask you for where do you want the origin to be. So the origin doesn't necessarily have to be at the bottom or at the other end. It can be anywhere you want it. This will basically become your insertion point when you actually go about creating more and more instances of this shape. Whenever you will enter this point, this is the orientation around which, this is the way the object will be created. So what you do is basically, now since I have the snappable points in front of me, all I need to do is I can select these shapes which I've created, and then enter the shape editor, so the shape database. And when I do that, this for mine is empty right now, but you could have an entire catalog of thousands of shapes in there, and those could be sorted according to different manufacturers and the different things which they produce. So you could have 10 different coupler manufacturers, and each coupler manufacturer would have 20 different types of couplers, and under each type you could have dozens of actual couplers. And you can create, so there's a uh, level tree structure over here. The first level is the manufacturer. So I'm going to add a manufacturer, and I'm just going to call the manufacturer M. You can give it any company name if you want. And when you do that, under the database, this manufacturer appears. Now, after I've done that, I can select this M, which represents the manufacturer, or I can create another manufacturer at the top level. But I'm going to select the manufacturer and say add a family. So this would be like this. Maybe this is a coupler manufacturer, and the family would then represent the type of coupler, the family of the coupler. So it could be an anchor or something else. So I create a family under the manufacturer, and then under that family, I actually create the actual item. The actual item. So under this family, under this coupler family, for example, or anchor family, I could have a dozen anchors or a dozen different couplers of different sizes, etc. So under this family, I say add the item. Now I've got the things selected in the background, if you remember. So when I say add item, it asks for a name. So I can give it any name. I can call it, let's call it coupler 1. Let's give it that name. And when I do that, since I've already selected, it directly goes on to ask me for the select origin point. If I hadn't selected it, it would have first asked me to select the objects. But since I entered the command with something selected already, it directly goes to the select origin point. So I'm going to select this as the origin point. It then asks for the X direction, a point on the X. So I'm going to give it this point as the X direction. And for the Y direction, I'm going to basically give it this point as my, and that's all you need. You need the origin, the X direction, and the Y direction. And the moment you do that, immediately under the M manufacturer, under the F family, coupler one is created. And if I were to select that, you would see the shape, a preview of the shape as well. And basically now what you've done is you've created your coupler. Now that we've created the basic shape and given it a name of coupler one, we can actually use it as well elsewhere in the model. So let's say I want to recreate those shapes elsewhere in the model. I just go to my shape database once again. Now this time it opens up with whatever I've created so far. Like I said, you could have dozens of couplers over here defined by your company. And I'm going to select coupler one because that's the only one I have. And then I'm going to say create. Now, when I say create, the only thing it's going to ask me is for my origin, for my x-axis, and for my y-axis. So let's take this one to be the origin. Instead of vertically upwards for the x direction, let's select this one to be the x direction, and let's select this one to be the y direction. And when I do that, and if I zoom in, you can immediately see that the insertion point is basically the point, is exactly that point, and it's pointing in this direction. And I have created a copy of my original definition. Now what I can do is I can select this one and right click and say copy, say linear, and say, okay, a distance of 500, I can make 4 or 5 copies of this. And immediately copies of the same item are created. And if I were to double click any one of them, you can see over here a slightly different version of the other dialog box opens up. And over here we have the geometry tab, and over here we have the data tab. And in the data tab, we can give each and every individual one of these a different name also if you want. I mean, normally these are off the shelf catalog items. So the default name could be coupler one, but you can give a modified name as well if you wanted to. And you can also give them user defined fields as well. What you can give them is you can select a material for them. You can select a discipline for them. You can select a usage for them. If you want, you can even make them part of the numbering process, which is not normally required because these are, like I said, off the shelf items. But if you were to actually say further make some modifications in one of them and not all of them, what you could do is, so you say you could make a cut on one of them, you could still theoretically put them through the numbering process, and you could also import them into, they're obviously imported into the drawings. That's the whole idea. And you can use all these other variables like exclude from dimensioning or do not annotate, or these are all the other variables which we've talked about in the other videos. And you can even give them formwork groups if you want to. Basically, all the generic solid fields you have at your disposal over here. But coming to the geometry tab over here, we have a certain amount of control over rotations around the X, Y, and Z axis. So this is the X axis. Now I've entered it like that. This is the way I've entered it. But if I were to, for example, give a Y rotation, give a 90-degree rotation about the Y axis, this is what I can do. Or another 90-degree around the Z axis, I can do that as well. So I've got these options of playing around with the coordinate system after having entered it as well. And what I can also do is give the origin a linear offset in the X, Y, or Z direction. Now let's try something else. Let's say we have created this basic shape and we've used it extensively in the model. Let's say we've used it in hundreds of different locations in the model, thousands of different locations in the model. But then something comes up and we realize that we had entered the shape either incorrectly or there's been some modification in the basic shape of this coupler, which we didn't know, or whatever this item is. Well, what we can do is we can redefine the shape. So let me go back to this definition area. I can recreate this. I don't have to keep the original versions. But what you can do is, for example, For example, I can go and double click on this bottom one and make it a bit bigger. Let's make it 250 instead of 200. And so it's a bit wider. And secondly, I'm going to make this top one a bit longer, so 120 instead of 50, the top cylinder. And let's say this is the way it should have been. Now, what you can do is you can just select as just like you did in the original definition of the shape. Go back into your shape editor, select the coupler, and this time go into the properties and press the properties button over there. And under the properties button, you have lots of options over here. And if there's an option called change geometry, and in the change geometry section, you have one button for redefining the geometry. And you've got several other buttons as well, which I'll talk about in a second. These have to do with the level of detail. But for the moment, let's focus on this one, this redefining of the geometry. And when I say redefine geometry, since I've already selected the new shape, the way it should be, now it's directly also once again asking me for the origin point. So I can select this point, select this point as the X direction. And for the Y direction, I can select this point over. Let me zoom in so to ensure that I'm not making a mistake. Yeah, that's the point. And when I do that, this is now redefined into this new shape. So if I say save, now the database has been changed. But the instances which we created, now I'm going to say close. The instances which we created are still the same. And for that, what I need to do is I need to say update all shapes. So I need to press this button, and when I do that, this new redefined geometry is applied to wherever or however many times I've used this shape in the model. So when I do that, it's changed, and now I can just turn this off and zoom in to my location where I had created them. And as you can see, they have all been modified. The base has become wider. The top cylinder has become longer. So my original definition has been modified everywhere in the model. Now, one more important topic which I need to talk about is level of detail. And as you know, these shapes can get complicated, and they can be much more complicated than this one which I just created on the screen. And they could consist of lots of circular parts, for example, or spherical parts. Basically, they could get so complex that if you have hundreds of their copies in the model, or thousands of their copies in the model, or tens of thousands of their copies in the model, your model could become very heavy and difficult to render and will slow you down. So what we have in COMOSYS is the option of creating a level of detail. And what that means is that when you're not all zoomed up, when you're really, really close, then the full shape is shown to you. But when you zoom out, then at appropriate distances, the program kind of simplifies the geometry to a much lower number of polygons. And as you go even further, you can modify it even more. And as you go even further, you can modify it even more. And basically, what you have is an option to have 3 or 4 levels of detail which you can define. And what you can eventually define is that when I'm really, really far, I don't even want it to be drawn. Or you can say I want it to be drawn just like a small line, for instance. Or if I'm at this level, I want it to be drawn as a box, for example. And when I'm at this level, I want it to be drawn as a line. And when I'm at this level, I want it to be drawn or not drawn at all or something. This is what we call level of detail. And if you remember, we went inside and we select these, and we went into the shape database to redefine, and we selected this one. It said properties, and inside the properties there was a change geometry tab which we used, and we talked about redefining the geometry. But what you can do is you can redefine the level of detail geometries as well. So this is the basic geometry. This is the full geometry, rather. This is the actual geometry of the shape. But you have 4 more geometries you can enter on top of that. And these would be simplified versions of the original geometry. So this would be the simplified level 1, which you would see when you're slightly far. This would be the simplified level 2, which would be when you're a little further. This would be level 3, and this would be level 4. And while you can also actually create primitives for those drawings as well. So you can actually go and define that when I'm at at LOD1 level, I just want this whole thing to look like a box, and you can create a box in this redefine. But you've got certain, so you can say just there are some easy features. If you just press this one, it's going to convert it into a bounding box from LOD at LOD1 level. You can create all of them into bounding boxes, or you can empty. You can clear that level as well. And what that would mean is that you want and you can clear that, and you can enter a line or something like that. And in that case, if by redefining the LOD level, in that case it will turn into a line. So I mean, these are a bit advanced options, but the point I'm trying to make is that when you have a model, and you don't need to use this 99% of the times, because COMOSYS will actually automatically create a level of details for you. So for example, when you use the primitives, this circle, for example, is divided into whatever 32 different sections, because it's circular. But automatically it's going to create level of details of, instead of 32, use 16, and now 8, and now 4, and now 2. It's going to do that even if you don't tell it. But if you want to override those standard behaviors, you have this option of using those commands which I just showed you. So to summarize at the end, once again, you will use the shape editor whenever you want to model something which you're going to buy off the shelf, and you have lots and lots of those in the model. So if you have just one, you don't really need to create the shape editor. But if you've got dozens or hundreds or thousands of those things repeating in the model, then it's a much better idea to use the shape editor to model them, put them in your company catalog. And the good thing about that is that your people will be able to use that definition in other models as well. And all you need to do for that is, for example, if I were to go to the preferences directory over here and scroll down, you will see a file called shape database somewhere. So yeah, there it is. It's an XML file, and this file will contain all the shapes that you have created in your shape editor, and you can just exchange these files between your team. Your team can take them from each other, or you can have a company-wide file. Basically, all the things which you create, you can make them project specific, and you can copy it over here. So that's a very nice way of storing away your shapes for your company. And like I said, I've already mentioned the various uses. You could use them for rebar couplers, you could use them for concrete spacers, you could use them for standard embedded parts, or basically anything which you feel you might need to have a specialized shape, which you also need to model, but it's going to be bought off the shelf. And then you can import that into your drawings. You can create your material lists based on that as well. So this is a very nice feature which will make the general modeling capabilities of COMOSYS very powerful for you, and it will give you the capability of creating very impressive models for your clients.